600 miles plus. So we've got 600 miles of flat, level Earth between sea level and the base of the mountain, according to the first two calculations taken by Al-Biruni, to get the height with trig. Okay. Why is it that when we then cut back to the picture of his extrapolation thereafter, the ground below him that he just utilised 600 miles of flat is now bending away from him? Why is that? To extrapolate out that the curved surface was what you used to get the triangles for the height? No, this is nonsense. Total nonsense.
Let's not miss the fact that we have two different videos claiming it was done, one by the seashore, the other one up there 642 miles. So when we say we don't even know some of these stories are true, this lends to that.
30 meters. I now need only one more measurement to get the size of the Earth. And to
let's hope they don't violate all of the other measurements you just took.
Get that, I have to climb to the top of the mountain.
The one you just measured the height off a flat baseline. Gotcha.
What Biruni did next was measure the angle of the line of sight to the horizon.
Okay. The one that was presumably used on the lake that you described because you weren't at sea level to ascertain a horizontal baseline to get the height. That horizon. Cool. Gotcha.
No.
It's a big-ass lake.
No, not that. He's using the horizon he couldn't see because of the mountains in the way.
Okay.
Below the horizontal.
Below the horizontal? Hold on a second. You just measured the horizontal to establish height. Now you're saying you can see below what you just walked along? That makes no sense. How can you be below the horizontal, the one you established as a baseline to get height? You can't be below the horizontal. What's he talking about? Would it be that he's talking about a dip to a geometric horizon that's below surface level in the geometric maths that follows this assumption by Biruni? Is that what he's talking about?
Yeah. He's drawing a line through the surface of Earth to a point that doesn't exist.
I see. Let's just hear him say that again. Let's just see exactly how he phrased it on Al-Biruni's behalf, of course.
What Biruni did next was measure the angle of the line of sight to the horizon as it dips below the horizontal.
The line of sight to the horizon as it dips below horizontal. That means you're seeing a line of sight to a horizon below where you can see. It's not a line of sight.
Well, but what he's doing is a dip from the horizontal that's created by the astrolabe on top of the mountain. So it's just a depression angle. He's already established a horizontal baseline using mean sea level to get the height of the mountain. So he can look at the sea horizon that he can't see because it's 600 miles away, and then use the depression angle from the horizontal he'll create on top of the mountain to then reify that into a ball Earth.
I see. So as John has detailed on numerous shows, he's taking the difference between surface level and eye level to infer that he can see below surface level when looking at the horizon. Right, this is nonsense.
But it's not called a level differential calculator for nothing. Oh, sorry, they don't call it.
They don't call it a level differential calculator, but that's what we ended up with. The Earth curve maths, and I hope John keeps stressing this throughout the time that we're doing these shows, is a differential calculator. It's calculating the difference between eye level, as this gentleman looks out towards the horizon, and surface level. And the dip between the two is what you get an extrapolated Earth curve below surface level in the maths.
So we're going to try and reproduce that. So if you can lift it up so that it's hanging, and if I locate the horizon, okay, which is about half a degree.
This is completely ignoring conflating variables like atmospheric refraction,
which is about the value that Biruni got. Now here's the really ingenious part. Biruni had measured 4 quantities, 3 angles and a distance. He used 2 of the angles and the distance to work out the height of the mountain.
On a flat plane? Why cut to a picture of a globe Earth in space? This is a second law of thermodynamics violation. If this black area is 10 to the minus 17 to a vacuum, all of these clouds and high pressure gas would just escape into this very high vacuum. So, no, definitely not. I don't know why you've cut to this, but you've just described the 3 angles, 2 of which were taken off a flat plane to get the height.
Al-Biruni now had everything he needed. In essence, Al-Biruni imagined a huge right-angled triangle, which has as its 3 corners the mountaintop, the horizon, and the center of the Earth.
But you've taken a dip.
Right angle.
Yeah. How's that geometric horizon working out for you guys who talk about dip corrections when in debate about celestial navigation?
This is completely ignoring conflating variables like atmospheric refraction.
What's that? You can correct for it being a straight line, but all of your lines are bent. They're all refracted. Why is it no Atmo Day?
Why is that a problem? There's no problem with it being all straight lines.
Because
To the edge of the globe is a straight line.
Yeah, meanwhile, Al-Biruni's just violated the first 2 measurements because the first measurement to take this here from surface level to the point at the top of the mountain, that's h, height. He did it off a flat plane he showed you earlier. In fact, let's bring that up on screen right now so we can compare and contrast how different these 2 images are. Notice how the right angle triangle in this image appears at the base of the mountain, and extending out, if the story is to be true, to sea level would be 600 miles plus. So we've got 600 miles of flat, level Earth between sea level and the base of the mountain, according to the first 2 calculations taken by Al-Biruni, to get the height with trig. Okay. Why is it that when we then cut back to the picture of his extrapolation thereafter, the ground below him that he just utilised 600 miles of flat is now bending away from him? Why is that? When all he's done is taken a differential between the surface level that he used to get the height and eye level at half a degree. To extrapolate out that the curved surface was what you used to get the triangles for the height? No, this is nonsense. Total nonsense.
No, it just
Trigonometry.
proves that. It just proves when he says to the center of the Earth that it's all coming from the equatorial plane, which is the flat surface we live on. Globe is surplus to requirement. Oh, this one's down. Go back to the first one because that guy's got it 642 miles away from where this guy did his. This is what's beautiful about the story. It keeps changing, and then they don't even know what right angle triangles are because they got to somehow squish it in on the surface of the globe where you can't get an elevation angle or 90 degrees or perpendicular or horizontal.
Which is basically a giant protractor with angles and degrees and a pointer to determine his line of sight. Now he had enough information to measure the height of the mountain using trigonometry and algebra. He needed only one more measurement to get the size of the Earth. Angle of the line of sight of the horizon as it dips below the horizontal. Now here's
Right, dips below the horizontal, the one that was used to establish a flat baseline for the 2 triangles to get the height. You can't look below the horizontal if the horizontal is surface level. You're describing something nonsensical. Seeing below surface level.
He's talking about the horizontal made with the astrolabe at the top of the mountain.
Yeah,
It's
the
back
dip
to
is...
reification.
Exactly. The dip is from the horizontal you establish with your eye line. So when he says, oh, it's half a degree, what, from your eye line down? Yeah, down to surface level is half a degree. But you then extrapolate that into meaning you can see below the surface level used to ascertain flat baselines for triangles. Makes no sense. It's stupid.
He's measuring the dip below the horizontal. He's made at the top of the mountain. But what the guy is not mentioning is that there's a second horizontal that was made originally, and that's at mean sea level to the base of the mountain. He's not telling you that he's measuring the dip between 2 horizontals, 2 parallels. That's what he's not telling you. He's only telling you about one horizontal.
So he's inferring that the eye line horizontal is somehow the same as the ground level horizontal when you take a dip to the earth curve that's fallen away from the ground level you were standing on at the base of the mountain. No. You've just taken a dip from the horizon, which was representing the ground, meeting your limitations of view, to you at altitude, and the dip thereof. Well, that's, as Brian's just detailed, and John details on almost every other show, that's a differential between two horizontal planes, eye level and surface level. How do we know? Well, because it's a straight line angle to it. It can't be anything else. You can't do this, by the way, Globers, in 2023. You don't have any straight lines to do it with.
Part. Al-Biruni imagined the mountain as a large right-angled triangle, which has three corners: the mountaintop, the horizon, and the center of the earth.
Why? When he just literally is bastardizing his original assertion, as shown in the other video, where this line here ran out, what, 600 miles? So that you could have a right angle at the base of the mountain. Where's that right angle gone now? Yeah, you notice how the right angle, again, we'll bring up both of the depictions. The right angle used to be at the base of this mountain. Why isn't it there anymore? Oh, because now, from the base of the mountain curves away at 8 inches per the mile squared. It's no longer a baseline. It no longer has a 90 degree in this extrapolation once he goes up the mountain. I mean, it's not like we used to have exactly that at the bottom of the mountain, a 90 degree with a flat baseline at sea level. Oh, we did, only until he climbed up the mountain, then he got amnesia and just forgot about establishing horizontal baselines that are then vanished from all existence in this diagram. Where's the 90 gone? Oh, the 90? Oh, well, that's a different 90 now. Now it's 90 at sea. Let's just bring up a clearer diagram of that. At sea, we've got a square there. Why has it moved? Why is it that we now have a box representing 90 degrees at tangent to a sphere where it was formerly at B, representative of the flat plane that you needed to do the trig to get the height of the mountain? Why has this box moved? Because you've used a differential calculator between two flat planes to then move out to that dip below surface level, that would be here, to a geometric horizon. It's just absurd, the fact that people have believed this for so long. Or the fact that mathematicians haven't recognised it when they're disseminating it, like in these videos.
Using trigonometry, Al-Biruni figured out that the angle of the horizon and the height of the mountain were related to the radius of the Earth.
Well, why didn't he recognise that when he was measuring the height of it in the first instance? So he didn't recognise that it was in relation to a non-90 degree at the bottom of the base of the mountain when he was measuring its height. But when he got up the top, he suddenly recognised that that 90 wasn't there anymore. It was actually a tangent point to a sphere.
You can't use trigonometry twice and come up with a sphere. You can't use trigonometry to gain your height to a mountain 600 miles away from mean sea level, because you'd have to know its height above mean sea level using trigonometry, using what's known as rise over run, which is horizontals and verticals. So you'd have to know all that to even do what he did, and then he's going to use trigonometry a second time. How do loads of triangles make up a sphere? They don't.